Yeah, a little bit of earthquake watch in the Alps. Oberkoms, there has been a quake 21 hours ago. Depth under epicenter 3 kilometers, which somehow would almost mean it's on where the Alps are starting to rise. Sea level. And I watched a little bit at the landscape. We have craters which have this kind of peatland features. They are reddish in color, and they are also aligned. Many of those craters, they are in a way aligned. And there's actually many alignments here in that, as you can obviously see by yourself. Many lines, and we have lakes with islands in the middle. And we have many, many water veins going from places where you, in a way, wouldn't expect to have water veins. And this is obviously a glacier here, what we are following here a little bit. That's a glacier, it's going to that direction. And here, it's in a way the end of the glacier. And once again, I ask the same question. Where is the pile? If according to USGS and geological commons theory, glaciers are carving out the valleys. Where's the pile? Where is it? This is the end of the glacier, and there's nothing in between, and then there's a lake. No pile. Nowhere. Not one single pile. But we find lakes, craters everywhere. Smaller ones and bigger ones. And some are fed from melting water, which comes from higher up. Some aren't. They are just there as a lake, sometimes in really high altitude. And now let's go a bit further out. Here was the quake, and then we have a valley which goes to the Lake of Geneva, and here is Brig, which happens once being in the news big time.
Am 24. September 1974 in Gefähr gekommen. Was man anfänglich ein bisschen unterschätzt hat, trifft nun plötzlich zu. Das Wasser bricht über die Ufer und überflutet die Innenstadt. Autoweg wird irgendwo in Schachten weggespült. Das Wasser baut sich seinen eigenen Weg. Und das mit brachialischer Gewalt. Sonnenwetter vom 24. September trifft Brig am härtesten. An der Saltina-Brigg türmt sich das Wasser, die Flüte stürzen über die Stadt. Die Naturgewalt zeigt sich von seiner schlimmsten, ja unvorstellbarsten Seite. Die Bevölkerung selber.
So obviously there has been a whole lot of water there. I have been there a few weeks after this, and I have to say it was a really big mess. So the place was here, the quake was here, and I noticed something interesting here. Let's go check it out quickly. This is, until now, one of the best examples I found of glaciers not doing what they are supposed to do according to what they told us in school. So it cannot be more obvious that here is the glacier end, where it's melting, and the water is flowing into that sea, lake. And we have a smaller lake here. Question is, why we have a lake here? Is this fed from underneath? There are interesting geological features because probably these are smaller lakes too, like really small. And Ulrichen, somewhere it said that's a place of worship. What happened now? Or was it that one? I'm not sure. But anyway, no pile in front of the glacier. And also here, there maybe once have been one glacier connected to each other. But no pile to be found. I made this funny little map here, trying to explain. Oh man. I tried to explain a little bit what we are looking at. The quake was here. The town which got flooded was somewhere here, or is still actually. I guess so. And the river Rhone goes here and there and then it goes into the Mediterranean, and there's other water bodies which feed into the same. But this is one water body, one of many what we have in Middle Europe. And it happens to be that we have also volcanoes in Germany, in Europe. 1, 2, 3, 4. And here, of course, in Italy, many of those. And here are those thermal baths I showed you recently, which have the most mineral-rich water, and they are the oldest, and blah, 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 you know. Basically like a volcano. What else geothermal activity could be than volcanic activity? And I was still wondering about how we have glaciers and how we have those wells in the mountains up high. And that's somehow a really simplified version of what I'm somehow trying to explain, but could be a possibility. Groundwater, and on top of it, we have the crust. If you have a river, like that's landscape, and here's the river, the actual water body might be much bigger than just what you can see on the surface. And that's a really, really simplified picture of, obviously you can see in the background there are many more mountains, and there's also a big valley which is going here behind. So we have electrical charge coming from above, like let's say whatever lightning discharge event or something. And we have the charge which is in the ground, which is also moving, telluric currents. And if they make a connection, and since we have groundwater here below, it might attract the water and this kind of stuff, that it will make the connection upwards. It goes through the crust, it pulls the water out there because it's really highly conductive. And water breaking through crust, let's say because of the electric current, or it might be just the whole ground has been softened before that, before the actual electrical discharge event through earthquakes, liquefaction, and these kind of things. So the whole ground is already really wet. And then we have the discharge, and in the background you see the valley, which is somehow, how to put it, the minus part of it. And then we have the mountains, which is the plus part. The minus goes down, the plus goes up. So it somehow, through electromagnetism and these kind of forces, what it creates, it starts to move the air, which means it can be really, really, really windy. Supersonic winds, for example. And it sucks in the material, vitrifies it, whatever there has been before. And through heat, it gets glued together, like welded. And when it's then done, you have a mountain range there. And of course, those lightning bolts, they are moving across the landscape. They're not in one place. They make one connection and then they move until the discharge or the charge equilibrium is again done between heavens and ground. So the discharge ends. The lightning bolt disappears. And because of the groundwater and conductivity conditions, or how to put it, of the water, it will rise up until it reaches the lightning bolt, because it's somehow the opposite of the lightning bolt. It is the thing which makes really the connection between heaven and earth, the water in this case, because these rocks aren't that metal bearing as other rocks you can find around the globe. So the thing which makes the conductivity, or which makes the whole thing work in order to make a connection between heavens and ground, is water in this case, I think. And this is why we find in the Alps like those water veins everywhere. For example, if you put the terrain on, it might show us water veins. Here's the quake. beside the crater. And there is just water pouring out of the mountains. Everywhere. Everywhere. And we have many craters. That's a nice example. There's just a lake and it's feeding this little water stream. So how would a glacier form this kind of indentation into the ground? And here's again maybe peat, remnants of peat. This lake is draining here, and this lake is draining here. So those two aren't connected. And they flow into that one. And then we have a really tiny lake here, spring or well, or however you put it. And there are many of those. And I would say that's the highest point, so the water goes to that direction and to that direction. I'm not exactly sure, but it's looking like that. Löffelhorn, a spoon mountain. Yeah, we don't need spoons here. We can see the matrix. Water pouring out of the mountains everywhere. Which could be a really good what is it in English? Proof for the electrical nature of the Alps, the role of water in the creation of the Alps. Groundwater got sucked up, and then it made it all. It was the thing which made the connection, the electrical connection, and through magnetic fields and material separation and these kind of things. Then the whole Alps got created. And if you watch a little bit from more high up, you can see like dendritical patterns everywhere. The whole Alp areas is one huge dendritical pattern. And this feature here is really interesting. This might be the plus and this might be the minus. There's too much text in this now, but I probably make once a video about this. And also these features here. What do you have? Campi Flegrei, Lagersee, and the Alps in between, which might be 12,000 years old. But I leave it here. Thanks.